In this video, we will go over a few examples of solving exponential equations involving compound interest. Compound interest is the idea that you're earning money on earning money. So if we deposit P dollars into some account that earns an annual rate of interest, R, and our interest is calculated or compounded N times per year, then after T years, the account will have A dollars. Now, T is in years. T can't be in months. T can't be in days. T has to be in years. R is a decimal. So, for example, 3% would have a R value of 0.03. And N is associated with quarterly or annually or monthly. That's how many times we calculate or compound our interest each year. In this example, we have $1,000 deposited in an account that pays 4% interest per year, compounded quarterly, and quarterly means 4 times per year. Find the amount in the account after 10 years with no withdrawals. So here's our compound interest formula, and what we're looking for is A. That's how much is in our account after a time period. Now we fill in the rest and see what we got. So our p-value is 1,000. Our rate is 0.04. Our n value, that's how many times we calculate or compound our interest in 1 year, is 4. And our exponent is 10 times 4. So this is not actually an exponential equation. We put this in our calculator and see what we get. Now you do need to be careful with calculators to make sure that it does what you want it to do. You should get $1,488.86. Now, how much of that was interest? Well, if we started with 1,000 and we ended up with $1,488.86, then we've earned $488.86 in interest. Here's another example. This person has to pay a lump sum of $6,000 in 5 years. So they're taking a loan out. So what amount deposited today that earns 3.1% will grow to $6,000 in 5 years? So in this case, our amount after a certain period of time is 6,000. What we don't know is the principal, the P. Now we do know our interest rate, 0.031. It's compounded annually, so that's just one time a year. That's why our N value is 1. The amount of time is 5. So here we have an equation. It's still not an exponential equation, but it's not one that's too difficult to solve. We are going to divide 6,000 by 1.031 to the 5th power, and you should get $5,150.60. So if she leaves that in an account for 5 years that earns 3.1% interest, she'll have the $6,000 when she needs it. Got the same gal. Now, what if she only has $5,000? She doesn't have $5,150. So what kind of interest rate does she need in order to make her $5,000 turn into $6,000? So again, we have A equals P times 1 plus R over N to the NT power. We fill in what we know. And remember that N was equal to 1 because it's 1 year, compounded 1 year. So we just have 5,000 equals 1 plus R to the 5th power. The first thing we're going to do is identify where the R is. It's inside the parentheses, and that parentheses is taken to the 5th power. So we can't really separate the 1 with the R right now. What we can do, though, is get rid of the 5,000. So we're going to start off by dividing by 5,000, and then we're going to take the 5th root of both sides, and then we take 6/5 to the 1/5 power, or the 5th root of 6/5, subtract 1, and we end up with approximately 3.71% is the interest rate she needs. Now, there's also something called continuous compounding. This is when your interest is compounded all the time. And here's how this works. If we take our original formula, A equals P times 1 plus R over N to the NT power, and we look at 1 plus 1 over N to the N power, what we see is that as N gets bigger, that value gets closer and closer to the number 2.71828. And remember that N is how many times I calculate or compound interest in a year. It turns out this number, 2.71828, that's a fixed number, and we give it a value like pi. Pi is the value 3.14, etc. Well, this number, 2.71828, that is E. And some of you may remember E from Algebra 2 classes where you talked about natural logarithms. Well, this is the same E. And here it is out to several decimal places. And when we have continuous compounding, we don't use the same formula we did before. What we have here is similar, but it's P times E to the RT power. Now, your calculator will give you the value E. It's typically a shift or a second function of the LN button. Here's an example. We start with $5,000 deposited in an account that pays 3% interest compounded continuously for 5 years. Find the total amount on deposit at the end of 5 years. So it's worded very similar as the previous ones, but it's not compounded quarterly or compounded monthly. It's compounded continuously, which means you need to use this formula, A equals PE to the RT. Since it wants to know the amount on deposit after a time period, we were trying to find the A value. So we simply replace our P, our principal, with $5,000. Our rate is 0.03, and our time is 5. And to put that in your calculator, you do 5,000 times second ln 0.03 times 5, close the parentheses, and you should get $5,809.17. It mentions here that if you had used daily compounding, that is an N value of 365 in the other formula, you would have 3 cents less than what we did with continuous compounding. Here we're going to compare some interest. So we found in the very first example that we started with $1,000. We ended up with $1,488.86. They want you to notice the difference between compounding it annually, that is calculating interest once a year, to semi-annually, that's twice a year, to quarterly, that's 4 times a year, to monthly, that's 12 times a year, to daily, that's 365 times a year, and finally to continuously, and that's that different formula. So there is a difference, but in most cases, for the amount of money we're starting with, it's not a gigantic amount of money.